We see self-driving cars on our streets all the time now. So it kind of begs the question, right? Why hasn't that same revolution happened on the huge open ocean? Today, we're going to dive into the surprising and frankly fascinating challenges of creating truly autonomous ships. And look, it's a totally fair question. You've got companies like Waymo with cars navigating the chaos of city traffic. You'd think the open ocean would be a piece of cake compared to that, right? Well, it turns out that couldn't be farther from the truth. The lessons we've learned on land just don't apply to the sea, and we're about to find out why. See, the real issue here starts with a huge misunderstanding we all seem to have. We picture the ocean as this giant, empty highway. But that's just not what it's like. It's actually one of the most chaotic and unpredictable environments on the entire planet. And this chart really just lays it all out, doesn't it? Autonomous cars work because our world, the land world, is structured. You've got roads, signs, traffic lights. There are rules. The sea, it has none of that. It is pure, unpredictable chaos. There are no fixed paths. You've got to deal with insane weather, giant waves, and powerful currents you can't even see. And that is why when you hear about an autonomous ship today, it's mostly just a really, really fancy autopilot. Sure, it can keep the ship pointed straight when the weather's nice, but the second things get a little hairy, a human has to jump in and take over. And that, my friends, is not real autonomy.
Okay, so if a simple autopilot isn't going to cut it, what's the answer? Well, researchers realized they needed to build something totally new. They needed an AI that doesn't just follow a pre-programmed route, but actually thinks like a seasoned human captain. And they gave it a pretty cool name, the Digital Navigator.
You know, the idea behind it is actually pretty brilliant and surprisingly simple. Basically, the Digital Navigator, or DN for short, is an AI that learns to be a digital clone of a top-tier human navigator. It literally watches what the best sailors see and then copies what they do, building this incredible intuition for how to handle a ship in pretty much any situation. So how do you actually build one of these? Well, it breaks down into 3 main steps. First, you've got to collect just a ton of data by watching and recording those expert humans. Second, you feed all that data to the machine learning algorithms to train the AI. And the final step is to pair that AI with what are called decision support systems. You can think of them as specialized co-pilots that help it crunch all the complex data it needs. But, this whole idea brings up a really thorny problem. Think about it. How in the world do you test an AI that's built specifically to prevent a disaster? I mean, you can't just steer 2 multi-million-dollar container ships at each other and cross your fingers that the AI works, right? The risk is just astronomical. And this quote from the research paper just hits the nail on the head. To really test the AI, you'd have to create these incredibly dangerous situations, collisions or near misses in the real world. A single slip-up could mean human casualties, an environmental disaster. It's just unthinkable. So this is the ultimate catch-22, isn't it? Before you can trust an AI with a massive ship and its crew, you have to know it can handle the absolute worst-case scenario. But you can never, ever risk creating that scenario in the real world to test it. So what do? The answer? You don't test it in the real ocean. You build a new ocean, a virtual one. This is what they call the sandbox for the sea. This sandbox environment is basically a super advanced VR simulator where this AI can be put through its paces over and over and over again. You can throw literally anything at it, the craziest storms, the most complicated traffic situations you can dream up, and there is absolutely zero real-world risk to anyone or anything. And this diagram shows you exactly how this whole setup works. It's pretty genius. Okay, so over on the left, you've got a real human sitting at a navigation station controlling a virtual ship. Then up top, there's a powerful computer running the AI, the Digital Navigator, which is controlling its own virtual ship. And here's the cool part. They're both operating in the exact same virtual world, interacting with each other as if they were really out on the ocean together. So let's break down the key pieces that make this all possible. You've got the VR simulator itself. That's the heart of it. Then the navigation station. That's where the human operator sits. The supercomputer acts as the AI's brain, and the real magic glue is this multi-communication interface. Think of it like a universal translator that lets the human, the AI, and the simulator all talk to each other perfectly. It lets you test every possible interaction between human and machine. And the single most important number in this whole system? It's 0. 0 people at risk, 0 ships at risk, 0 environmental damage. It allows you to be incredibly tough on the AI, pushing it to its limits in ways you could never, ever do in the real world. But it's really important to understand this sandbox isn't just some fancy video game. It is the absolutely essential bridge that connects all this virtual training to real-world operations, creating a clear and safe path forward. Okay, now this next part shows how they take it to the next level. This diagram looks a little complicated, but stick with me. That box in the middle that says Remote Operations Center, that's our sandbox we've been talking about. Now follow the lines down. The real magic is how it connects through the network to an actual physical research vessel out on the water, the Ymir. This means the exact same AI, trained and perfected in the simulator, can then be used to control a real ship from land. It's the ultimate test drive. So this gives us a clear roadmap to full autonomy. Right now, we're in the first phase, sandbox training. The next big step is remote operation, when the tech is good enough to reliably control ships from shore. And only after that is proven to be safe can we finally get to the future, full autonomy, where the ship does its own thing and those remote centers are just there for backup in a real emergency. And all of this, really, brings us to the final and maybe most important question. Because with a system like this sandbox, we can build the technology, we can prove it works, we can make it incredibly safe. But the last hurdle isn't technical at all. It's about trust. After all is said and done, after all the simulations and all the tests, are we as humans ready to truly hand over the helm?